Hi everyone, Mr. Neighbor here, and in this video we're going to still talk about motion graphs. But for this video, I'm going to do for you is I'm going to show you a bunch of motion graphs, and I'm going to give you some time to look at it and kind of figure out what you think is going on, and then I'm going to talk about what is going on. So in all of these, think about a person, and that person is moving in some way. They are moving at a constant speed. They are moving at increasing speed. They are moving at a decreasing speed. Their position is changing rapidly. Their position is changing at a constant rate. Their position is slowing down or changing at a slow rate. Use those type of words when talking about this. Okay, so first, let's look at the graph, and you try to come up with a situation for this one. So this is a displacement time graph. So the person is starting 4 meters from wherever the observer is measuring. They're staying there for 10 seconds because the position is not changing. Then they're moving back to their home position at a constant rate. So maybe they're walking backwards because they were a certain distance ahead, and now they're going back to their starting position. Because remember, this is a linear motion. It's not a twisty path. It's just forward and backward or up and down, one of those two. So the speed is constant, but the speed would be negative. Then they get back home, and then they go forward at a constant rate, and then once they get there, they're going to go backwards again. They're going to go back to the starting position and then past the starting position even and back further yet. And they're going to do that at a constant speed. That speed is actually faster than these two speeds though. I know that because the slope is faster. Then they're going to stay put for a time, and then they are slowly going to walk back toward the home position. And that's going to be the slowest speed they have. All right, let's talk about this one. So think of a situation and then I'll explain. This is a velocity versus time graph, a little bit harder to think about. So in this first section right here, we don't actually know where this person is starting out at. This is not a position time graph. We have no idea where they're starting. We only know how their speed or velocity is changing. So here, they're starting at 0, they're at rest, and then they speed up to about 10 meters per second. Then they stay at that constant speed of 10 meters per second. So they put on the cruise control. Their distance is changing at a constant rate. Their velocity is not changing during this section. Then they begin to accelerate at a constant rate. They hit on the gas pedal and they speed up. They speed up faster than they were here. I know that because the slope is higher. If you were to calculate the change in velocity from this point to this point, you would see this is different than this, and it's more in 3. So they speed up, and then they slow down. They hit the brakes or just let it slowly decrease speed until they get right here where the speed is 0. At that point, they're now going to move in the reverse direction because here is negative velocity. So they're accelerating backwards to the point where they get to a speed they want, and then they continue at that speed backwards. Okay, so there's some backward motion right here. A little hint, whenever you see a slope on a velocity time graph, that means there is acceleration. Whenever you see slope on a displacement or position time graph, that means velocity changing. All right, let's look at this one. So think of a situation first. Here we have a velocity time graph. Remember, we know nothing of the position from this, only if the position's changing. So we don't know where the position's starting at. We don't know where home is at. We do know that this person started by not moving. They were at rest, and they stayed at rest for 2 seconds. Then they began to move backward. So their speed increased in the negative direction. They had a negative velocity. So they moved backwards at an increasing rate to right here. And then they moved forward at an increasing rate right here. This is a steeper line than this, so this acceleration was more than this acceleration's magnitude. Once they were done speeding up, then they put on the cruise control and stayed at 2 meters per second. Then they decided to slow down right here. The velocity, decreased to 0. And then this is slowing down. This is speeding up in the opposite direction. So they're traveling backwards in the reverse direction. Maybe they're not putting the car in reverse, but they're moving in the opposite direction that they were. They were going right, now they're going left. And they're speeding up in the left direction until they're moving at 6 meters per second. Left. That's what the -6 means. Then they slow down to -2 meters per second, and they stay at a constant rate of -2 meters per second. So they're jogging, putting on the cruise control, still going backwards though. And then they slow down some more until they come to a stop. So lots of backward motion here. All right, here's another velocity time graph. So think of a situation with this one. All right, velocity time graph doesn't tell us anything about position. We only know how the velocity is changing. So we're starting at rest, and then immediately we're accelerating, and then we're accelerating even more because that line is steeper yet. Then after we're done accelerating, we're holding constant, putting on the cruise control. Then we're taking off the cruise control and slowing down at a constant rate. Then we begin speeding back up at a constant rate, and then speeding back up even faster at a different constant rate until we get to 8 meters per second, and then we hold that steady and put on the cruise control, and we end at 8 meters per second. All right. Now, this last one, it's an acceleration versus time graph. We have not talked about acceleration yet, but go ahead and try to think of a situation that this would work with, and then I'll explain mine. All right, so first, 0 acceleration means that we are not speeding up and we are not slowing down. However, it doesn't mean that we're not moving. If you're moving at 2 meters per second constantly, you aren't speeding up and you're not slowing down, but you're moving and you still have an acceleration of 0. You're not being pushed into your seat at all or being flung into your seatbelt at all, but you're still moving if you're moving at 2 meters per second, but there is no acceleration. So right now we are accelerating. So we're being pushed back into our seat. And then we're increasing that acceleration. So we're moving and changing our velocity even faster. And then we get to the speed that we wanted, and now we're on cruise control, so we don't feel pushed and we don't feel flung into our seatbelt. Then we're decelerating right now. A negative acceleration means we're fighting the motion we're going in. If we're going straight, the acceleration backwards means we're slowing down, so we're being flung into the seatbelt for this amount of time. Then it's a positive 1 meter per second squared. So that means we're accelerating forward in the direction of motion. So we're being pushed back into our seat. Then it changes to 3 meters per second squared. So we're being flung into our seat even more until we get to 0, where we're not flung into our seat. We're cruising, or we came to a stop. But because this was continually going up, we're constantly being pushed back into our seat. The constant of 0 means that we're at cruise control. We're actually moving right now. But I can't really say that for certain because I don't know what my initial velocity is. Maybe we are stopped, but I don't know for certain. But if we started at rest at 0 meters per second, then right here we would be still moving.